can read the definition by yourself. You have to give an input, get the output, and you have to compare the output. Right? That's what we saw. Right? So that's how the AT is automatic test equipment, or you call it tester for short. So what is the device and what is the test data? Right? What do we test? We can select system, board, okay, chip, a die on the wafer, right? Or a core on a die, section of the core. So you have seen all these things in the last class. Just for reviewing, I'm doing this. Okay. So give a test pattern, you give a test set, you store the response. You can have a functional test or structural test. Functional test test the functionality, and structural test continue your scan test, IDDQ test, PTPG, all those kind of things, or memory based, logic based, compression test, boundary scan. They are the test structural tests. So we need to have a golden model to compare the data. Then you compare the outputs. Okay. Test board. What is a test board or a load board? We call in a tester. There's something called a load board. We'll see that when you go to a ATE thing. So I want your feedback. When do you want to visit? I put the code somewhere. If you're interested, then we'll do. I'll kind of assess your how much you understood on the test. Then we'll take you. Otherwise, it's a waste of time for everyone, right? It's a waste of money. If you're up to some certain knowledge, if you're able to ask right questions, then we'll take the test. Otherwise, no. It's all. I have certain expectations. You have to meet my expectations. Then we'll take you outside. Okay. So there is something called load board in an ATE machine. We'll talk about that later. On the test board, it's called something called backplane. So backplane is typically, if you look at a motherboard in older systems. So backplane is a plane where motherboard is something like backplane. You can put multiple add-on cards into the particular motherboard, right? You have backplane, on that you can add multiple system boards into that. And the test bus is connecting all of them, right? So this is a description you can read. So this is called test board. You have backplane. And this is this particular textbook. You can see the details, right? There's a Nawabi is the textbook. You can open that particular book and read more about this. This is how test 4 is looking like. These are the ATE machines. You can do micron.com. Can see. So there are different lights will be there, like traffic lights. Green is that everything is going okay. It's ATE machines. Everything is going okay. And red is a fail. Yellow is you need some attention. Right? This is the ATE. It consists of processor, it consists of storage, and it contains fixture for mounting devices. ATEs are used for die level testing, wafer level testing, or testing a package pattern. We already saw that. So it runs a test program that tests the specific procedure designed for testing the DUT. Right? Can do concurrently can test multiple dies or chips. It's called multi-site testing, or you can do concurrent testing also. You can concurrent test multiple features in a design. That also you can do it. What is the details? We'll see in advanced topic. I'll get a guest lecture if you are interested. So these are details of a test your mainframe computer. Said that test program is running on the ATE. This is a test head, and you have your DUT or on a load board. I told you there's a load board. So I'll have an expert to come and talk about all these things to you later on, based on your interest again. We'll study the month of September based on the interest availability. There's a console where you can control the tester. Console is basically a display and a keyboard. This is a load board, right? You can see there's a socket where you put the DUT inside that. The front and back, it looks like this, right? There's basically a list of pins, everything available, and this is what it, and you have to fix that in the overall board. Okay. So this is something called a load board. It's going to how to interface that to the ATE machine. So load board is basically interface between the chip or DUT and the ATE machine. Right. When we visit the ATE tester site, we'll see what is the load board, how it is designed. You can find out, right? So this is a typical wafer setup. Yeah, it's graphical. You can see it. We have kind of shown the similar diagram before. And what are the needs for testing? So functional testing. We saw about functional testing and structural testing, right? So functional systems perform functional testing to ensure that ICs operate as needed. That is functional testing. This involves applying input signals, verifying the corresponding output responses. Your simulator will give the correct response. So your DUT will the actual silicon will give a different response. The tester will match the expected response, the actual response, and say test pass or fail. Right? If you run any lab one, if you can do it, you will understand what it is. I asked you to automate the test bench, right? So your ATE is very similar to that. Yeah, I think yeah, you can ask me questions in the today's class. Performance testing, why you do that? To make the key performance index, KPI, such as speed, power consumption, signal integrity, area, blah, 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 blah. There are a lot of things will be there as a performance metrics, right? So that we can do performance testing in ATE. Parametric testing can do similarly, can test the voltage, AC/DC parameters we spoke about, right? Voltage levels, current levels, frequency response, timing accuracy, and fault detection. Can detect the manufacturing defect, shards open, ATPG test. Can run it. Stress testing, install test, SCOL test. You can run that. Compatibility test. You can check your device is compatible with other standards or not. Accuracy and precision. You can check how accurate and precise the parameters are there. The specifications what you are specified, right? Reliability you can check. We already spoke about that. Repeatability. What is the difference? You need to read and understand. I'm not going to do that. Basically, this is self-learning. I would probably stop that and leave it out, and you have to read it yourself and ask me questions. I'll pause the video, read it yourself, ask me if you have any questions. Pause the video. Okay, what is the conclusion? Why test is required? Yeah, again, you read it yourself. Rules of 10, we revised about it. We have to optimize everything. There's no best solution for all. There's nothing called ideal wife or ideal spouse. Right? I don't offend the female gender. So there's no ideal spouse. Right? There's no ideal anything. They are good, sometimes they're very good to you, sometimes very bad to you. Right? I'm strict to you, say you have to submit your lab assignments on time. So I become a bad man to you. Right? Sometimes they're very friendly with you. Your friends also become very bad friend at times. If somebody questions you, you become bad, right? Truth is always bitter, correct? Who is responsible? Very fantastic question. Everyone's responsible. I told you, right? This is somebody. Person who's using a design, who's verifying reliability, the tool vendor, PFE, I don't know, I took it from some fabrication, testing house, production house, test engineer, everyone has play a role to test. Okay. That's pretty much of the first chapter. Yeah, so revise the things, guys, properly and ask me if you have any questions. We'll directly go to the second chapter. No. Thank you. Wish you all the best. Bye bye.